friends, once again welcome to Passion Tronic, my YouTube channel. Ashok Jadhav welcomes you. Friends, today I will explain you how to write a small program for getting 1's complement and 2's complement of an 8-bit number. You know that why these 1's complement, 2's complements are important. 1's complement form or 2's complement form is required for computer arithmetic operation. Actually, these 1's and 2's complement simplify the subtraction operation. Let us study. Of course, I will be showing you the total process with the help of flowchart and how to write the program. And of course, we will see it, we shall discuss it through the one assembly language programming example. So let us see that. Look at this. This is just a programming example. Write an ALP to get 1's complement of an 8-bit number given at memory location C256H and store the result in next location, that is C257H. Here we have chosen two locations of our choice, we can say. The number is given in the memory location. We just get the number out of the memory, get its 1's complement and store the result at desired location. Right now you know that how to get the number out of memory, how to get the number from memory into the register, CPU register, and you know that all the process is performed in microprocessor. So let us see this. On left hand side here I have shown here address and content. So actually this is the RAM, and see that the number n, which is 8-bit binary number, that is stored at C256hex. This is the address of that memory location. So in order to get the 1's complement, you should get this number out of the memory. So somehow get this number, and you know that what is the instruction used for that. So get that number into accumulator. So the nature, the process is described here with the help of this flowchart. So let us start here, and the first step is that as we want to access memory, therefore pointer, which is HL pair, that has to be initialized at C256H. So somehow get the address of that number into memory pointer, which we use usually is a HL pair, right? And then next step is that get that number into accumulator, because it is the accumulator and the ALU that process the data. So next task will be, with the help of pointer, get the number into accumulator, then use some logical instruction, get its 1's complement. The third step is find its 1's complement. So write appropriate instruction for that, and when this instruction is executed, its 1's complement will be ready in the accumulator, and the only task remaining is that we want to store that result into particular memory location, next memory location. And again, it is very easy to get the next address, to get the address of next memory location when pointer is initialized. So increment HL pair, use that instruction to get address for storing the result, and then store the result, use the appropriate instruction for that, and that will be stored and then stop. So this is the nature of, you can say, the total process, and it is described by flowcharts. So let us write program for that, and here I have drawn both flowchart on left hand side and corresponding assembly language program for getting 1's complement. So let us start step by step. The first step here is we want to initialize pointer, and therefore the instruction should be load HL pair immediate. And what is the address we want there? C256, because this is the address of that byte. And that's why in comment field you see pointer equal to C256 hex in HL pair. And you know that Alexa H and this 16-bit quantity which is given in the instruction itself gets loaded into HL pair. So pointer is ready. Then the next instruction, the next task is getting that that byte into accumulator. So here, this is this. See here, the instruction use is move to accumulator. So this is destination from memory, and you know that whenever there is a memory mentioned in the this assembly code, the address is assumed from the HL pair, and which is in this case is C256. So accumulator will get loaded with the desired number. And we have studied one instruction from the logical operation, complement accumulator, CMA. So when this instruction is executed, its one's complement is ready in accumulator. Okay. Now we want a pointer ready to store the result, and we want to store it in the very next location. So update pointer to HL, that means C257. Initially it was loaded with the address C256, and in order to get the next number we just increment HL pair, and therefore the instruction used here is INX increment HL pair. So again pointer is ready for memory access, and only task remaining is that storing, and that's why store the result at location C257. The instruction required here is move MA, move to memory from accumulator. Reverse of this, here we have used move to accumulator from memory, here we want move to memory from accumulator, and of course the result will be stored, and the last instruction is halt, that is stop. You see how easy it is to write a program for 1's complement. Now what if you are asked, if you wish to write the same program but for 2's complement, and that is very easy with just slightest modification using one more instruction there, you will get the 2's complement. And you know that 2's complement is nothing but 1's complement plus 1's complement plus 1. So let us consider the next slide. Suppose that there is another problem assignment like this: write an assembly language program to get 2's complement of an 8-bit number. So here in problem you are asked say 2's complement of 8-bit number given at memory location. Now I have taken different address CA23, number is assumed in CA23, and we want to store the result in next location CA24, and therefore the RAM picture in memory, see here at CA23 we have taken this number, and we want result to be stored at CA24. So naturally what we have to do, just get this number into accumulators. Of course for accessing this number we will have to initialize the pointer, and therefore the first task should be pointer equal to CA23. Why CA23? Because the number is given there, so we have initialized the pointer, the address of the given number, right? The next is get the number into accumulator. In order to process it, the number should be in the accumulator, so get it into accumulator, and then next step will be get its 2's complement. So find its 2's complement or write appropriate instruction, and you will get the result in accumulator side. And the next, that is we want to update pointer, because we want to store that result, that is 2's complement in this case, in next location. Therefore, in order to get next location, we have to increment the HL pair, and finally store the result at CA24. Why CA24? Because you have incremented it, and then just stop there, right? So let us consider the actual program, how it should be. See here, let me remove these things. Now we have here flowchart and its equivalent or corresponding assembly language program adjacent. The statement is again written just for pointer reference. Now the first step is that we want to initialize the pointer. Okay, so here, look here, pointer, initialize pointer to CA23, because the data is given there, and that's why the instruction use again load HL pair with the address of that number, which is CA23 in this case. Now HL is loaded, HL is ready for memory access, and now instruction, just in case of last program we have used here move AM. So how to read this? Move to accumulator from memory. So get the number into accumulator. This is comment. Then use complement accumulator. The instruction is same as we use in the last program. So get its first complement. But you know that in order to get 2's complement, our aim is to get 2's complement. And 2's complement, this gives you first complement. And incrementing means actually what you are doing, you are adding 1 to the accumulator. With this instruction you get 1's complement, and by incrementing it the result will be 2's complement. Therefore the comment I have written here is add 1 to get 2's complement. So with this instruction the result will be read in the accumulator, and again we want to store it in the next location. And how to get next location address, how to update the pointer, just by incrementing it, by adding 1 to HL pair. The address in HL pair would be CA24, because earlier we have initialized it to CA23, so this will be CA24. And then move to memory, because the result is ready in the accumulator, so move to memory from accumulator. So store the result at location CA24, that's the comment. And then last instruction, our favorite instruction, is that is halt, stop process. So this is how you can write simple program. These two programs are part of the our syllabus unit 3. Actually we are studying some programs for that is unit 3. Okay, I hope that you have understood how to write the assembly language program and how to find 1's complement and 2's complements. So it is time to stop here. Love you all. Bye.